Yay! Monday is here. So let's do some maths. Awesome maths, extreme maths, if you will. This is set 8 of our do nows, so you know the drill by now. I'm going to start the stopwatch clock thing. You're going to do your maths, and then we'll stop it and do the answers. Okay, you've got 5 minutes starting. Wait for it. Now. 4, 3, 2, 1. Thunder Maths is go. Right, so we've got a bag containing 10 discs. Each disc is labelled with a different number from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. A disc is chosen from the bag at random. Write down the probability that the disc is the number 3. Well, how many of the discs have got number 3 on? Well, that would be 1 out of 10. Now, with probability, you can give your answer in probability usually in 3 different ways, either as a fraction, a decimal, or a percentage. So you might have also written 0.1, so let's put a little or in there, or you might have written a percentage, which would be 10%. Okay. A number less than 4. Well, there are 3 numbers less than 4, 1, 2, and 3, out of 10. Now that would be 0.3 if you'd written it as a decimal, or it would have been 30% if you'd written it as a percentage. A square number. Well, the square numbers are 1, 4, 9, 16, and so on, but we don't want anything above 9 anyway. So again, there are 3 square numbers there out of the numbers we've got. So 3 out of 10, and again, 0.3 or 30%. Prime numbers. Well, the prime numbers, let's change colour for this. The prime numbers, the numbers that have got exactly 2 factors, namely 1 and itself. You can divide it by 1 and itself, but nothing else. A prime number, no, not 1. What am I talking about? It's not a first prime number. First prime number is 2, then 3, then 5, then 7, and then 11, and so on. But we're only interested in the ones that are on these discs from 1 to 10. So that's 1, 2, 3, 4. So that would be 4 out of 10. Or it would have been 0.4, or it would have been 40%, depending which you wrote. Now, for the rest of the questions, or sorry, this second question, I'm just going to do fractions, all right? It's easier. Right, a bag contains 8 blue and 5 red counters. So that is a total of 8 plus 5, which is 13 different counters. Counter is selected at random. The colour is noted, then replaced. That's important. Let's put back in. Another counter is selected. Draw a probability tree for these events. So when we draw our first counter out, it might be blue. It might be red. And the probability of blue would be 8 out of 13. And the probability of red would be 5 out of 13. Notice that 8 out of 13 and 5 out of 13, add those together, it totals 1, as in 13/13ths. It's a whole number 1. Now that's the first counter. The second counter then would be this second set of branches. And I could select a blue or a red or a blue or a red, depending on which set of branches I've gone down on the first counter I took out. So that's the first set. And then this is the second set. So probabilities go along the branch. The result is at the end of the branch. Now, probability of blue, it doesn't matter what I selected the first time. Because it's replaced, we have the same number of blue, which is 8 out of 13. And we have the same number of red, which is 5 out of 13. Now, there's no reason why I've put blue on top and red underneath. You could have just as easily done it the other way round. And the set of probabilities on these branches are the same, 8/13ths and 5/13ths. Over here, frequency tree. Now, frequency tree is different to a probability tree because it doesn't show probability. It shows frequency. Now, frequency is just another name in maths usually for how many. Yeah, so I got confused with what I was writing there. How many, that should say. How many is basically what we mean by frequency. Right, with the frequency tree, the number at the start is the total number of things, and then we've got some options going along. So, morning appointment, evening appointment. Now, we don't know what this is about, but let's say people had a morning appointment, 23 of them. How many had the evening appointment? Well, these two branches, coming off of 40, need to add up to 40, so that should be 17. Okay, frequency trees are pretty straightforward. Just make sure your set of branches adds up to the one before. So on time, of the ones that did the morning appointment, there were 23. 21 were on time. And so late, there must have been 2. It needs to add up to the previous sort of lozenge, previous, let's try that again, previous bubble. Now, the evening appointments, there were more lates. There were 5 out of the 17 people were late, which means there must have been 12 people on time. Again, they need to add up to the previous bubble. Okay, and if we added up all 4 of these at the end, they should also add up to 40. So 23, 35, 40. Yeah, good. Okay, off to your main task you go. Farewell. Bye-bye.